everyone. I hope you're doing well. My name is Zahra, PhD student at the University of Nozar, Faculty of Science, Morocco. Today I will present you my work, which is entitled Monthly Time Series Analysis of Canary Upwelling System Variabilities based on satellite data. My work will contain introduction, data and methods, results and discussion, and conclusion. Canary current large marine ecosystem is considered the major upwelling of the northwestern coast of Africa. It expands south, starting with the Canary Islands, Moroccan Atlantic coast, Mauritania, Senegal, Guinea-Bissau, and Gambia, but also Cape Verde and the waters of Kenya are considered adjacent area within the Seselimu areas of influence. The Seselimu is highly influenced by Canary current, which is flow along the African coast from the north to the south between the latitude 30 degrees north to 9 degrees north and offshore up to 20 degrees west. Being one of the world's major boundary current system with upwelling cold water. In terms of primary production, it is the third largest in the world after the Humboldt and Bengal large marine ecosystem and has the highest fisheries production of all African large marine ecosystem. Extended from the North Morocco to southern Guinea, the Canary Current forms the eastern boundary of the subtropical North Atlantic Gyre and flows parallel to the continent of northwestern Africa. The Canary Current region displays a great geographical variabilities, resulting in highly diverse upwelling ecosystem or environment. We have chosen 5 sites for this study in the Canary Current. SST data of 2020 was used in this paper. We have chosen to use monthly images to facilitate seasonal interpretation to obtain reasonable temporal resolution. In this study, we used also the observation provided by our wind library for statistical calculation and graphing. This library is specially designed to download and process wind and current data from the global forecasting system. In particular, monthly wind field have used the parameters chosen in our analysis were the wind speed and direction for 2020. Monthly chlorophyll data for 2020 of Moody's Aqua were obtained from AirDAP of the Canary Current region using the extractor 3D function in R. Upwelling index can be defined as the Ekman transport compartment in direction perpendicular to the coastline, following this equation. According to the results, for Site 1, the maximum upwelling index value occurred in July, reaching 75. Contrary to winter, which occurs the minimum value, the same case for Site 2, the upwelling index in July reaches its maximum of 100. For Site 3, upwelling index value is high all year round, but are slightly higher in spring and fall than in other seasons. For the Site 4 and 5, the upwelling activity is slightly high in winter and spring, which reaches its maximum on April 750 for Site 4 and 1600 for Site 5. Positive value in the upwelling index indicate an increase of upwelling strength during the June and July periods. Positive value occur in the northern region of Canary Current large marine ecosystem ranging from 0 to 100, while in August and September negative upwelling indexes value in sites 3 and 4 and 5 tend to decline and tend to be negative. Upwelling appears to occur all year round along certain favorable coastal areas, but occurs at its maximum intensity from January to May between the latitude 15 degrees north and 21 degrees north. There is the strongest annual upwelling in the spring and winter. This is because the north of 21 degrees north coastal upwelling generally peaks in summer and early autumn. The peak season in the north region of coastal upwelling is in summer, when regional trade is well developed, but south of the latitude 20 degrees north, upwelling ceases just at that period. The results reveal for the wind force considerable variation in wind along with the Canary current large marine ecosystem during winter and spring between 21 degrees north and 11 degrees north, and the wind speed varies between 4 meters per second and 8 meters per second. It gets weaker during summer from 0 to 4 meters per second, except for the latitude between 20 degrees north and 36 degrees north, in which the wind gets stronger, 4 to 8 meters per second. Summer and early fall, it also aligns with the coast direction. Wind upwelling favorable conditions were dominant during the whole year, especially for the latitude between 25 degrees north and 13 degrees north, with favorable events during the winter months, December and February, and the relaxation phase during the fall late, which is November, and late spring, which is May. All through the latitude between 36 degrees north and 20 degrees north presents the highest wind speed during months and the weakest wind speed during winter. This can be explained by the trade winds that come from the northeast in winter and during the summer. The intertropical convergence zone moves north and the trade winds gradually weaken. The hot season begins in July, when the more variable and less intense muson wind begin to blow from the southwest. For the sea surface temperature analysis using satellite imagery, the annual cycle of SST follows the seasonal fluctuation outlined by the upwelling index. The sea surface temperature increases gradually from the north to the south. In winter, sea surface temperature along the coast of northwest Africa are fairly uniform between 36 degrees north and 25 degrees north, slightly higher in the open ocean than onshore in the northern region. In the north, seasonal upwelling is not seen in winter due to the low sea surface temperature everywhere. To the south, this difference increases from 2 degrees Celsius to 3 degrees Celsius. Spring SST is the lowest in March and the highest in September. Spring temperature in open ocean are 2 to 3 degrees higher than in winter. The shelf temperature remain as low as the previous season between 25 degrees Celsius and 15 degrees Celsius. In summer, coastal temperature remain about the same and can be locally lower than in spring, but seasonal warming continue in the open ocean. Summer is the peak season for upwelling along the northern coast. The SST cross shore is gradually stronger. The average SST value was almost evenly distributed in winter, but there was a strong temperature gradient perpendicular to the coast in summer and autumn. The temporal variation of chlorophyll concentration along with Canary current large marine ecosystem, the highest concentration can be observed for Site 3. The maximum chlorophyll concentration, 6 mg per meter cube, occurs in April. The values are much lower than those along the northern region of Canary current large marine ecosystem, but the maximum chlorophyll concentration can also be observed in Site 1 and Site 2. On the northwest coast of Africa, the northernmost point show higher value, showing a pattern fluctuation throughout the year. The maximum concentration were observed in spring in the northern region of Canary current large marine ecosystem. Chlorophyll variabilities have a lower amplitude than along the Canary current large marine ecosystem, showing the maxima in winter and spring and minima in summer. In this paper, we analyzed the upwelling phenomena along with the Canary current large marine ecosystem during the year of 2020 to compare the upwelling activity in every part of Canary current large marine ecosystem. We selected 5 representative regions to study quantitatively the fluctuation of upwelling index. Regions of high upwelling are identified at Site 3 during spring-summer season and around Site 1 and 2 during summer periods. For the upwelling intensity, the autumn and winter season shows the highest intensity at Site 4 and 5. The maximum of upwelling intensity occurs during winter and spring seasons. The upwelling index does not provide a definitive answer to the intensification of upwelling along the Canary current region, so we considered the forcing field to promote the upwelling phenomena, that is, the compartment of wind speed and direction along with the coast. We have taken into account also sea surface temperature and chlorophyll A over the entire period of SST increases and in coastal offshore waters range from 1 degree Celsius to 2 degrees Celsius to 3 degrees Celsius in autumn, winter, and spring, summer, respectively. However, changes in sea surface temperature do not fully correlate with increased wind speed. And thank you so much for your attention.